Hello, people. How you doing today? Here's the thing. I'm going to talk about cosmology today. And I'd appreciate it if you sent this to any cosmologists you know, or your professor, whoever. Here's the thing. I've I've never been happy with the Big Bang Theory, and I've been kind of studying things for a long time, for 30 years or so. And I have my own theory, and I call it the popcorn universe theory. Now, I don't even think it's really the real truth because when you contemplate how gigantic the universe is, none of these theories make sense, really. I mean, they just seem so, it's so preposterously large that it's difficult for any one kind of theory to make sense. Certainly, the Big Bang Theory is just ridiculous, I think. And singularities, I think that's just a mathematical faux pas. And Hawking radiation, sure, when plasma is circling a black hole and it's giving off radiation, you can call that Hawking radiation. But the whole idea that black holes evaporate, I'm not buying that either. So let me get started here. I think we know what a black hole is. It's pretty much the same as a neutron star. And sure, when a neutron star is heavy enough to bend light, it suddenly becomes a black hole. But that doesn't mean that it automatically, infinitely contracts into this, singularity. It doesn't collapse that much. Sure, it may collapse somewhat. The more gravity, the more collapse. In fact, I think the center of a black hole, the center of the neutron star in the black hole, if you will, probably stops all movement. There's probably so much pressure that it's like solid neutrons or whatever's in there, mostly neutrons, I guess. And they may transform. But here's the thing. So I have the I call exponential gravity theory, but it's really not. Well, I call it that. But if you drop a marshmallow into a black hole, okay, so the weight of the marshmallow, and then there's plus, so there's neutrons in the marshmallow, but there's also electrons and protons. And we know that under extreme pressure, electrons and protons can collapse into more neutrons. So wouldn't that mean that the total substance of the marshmallow would weigh more after it falls into the black hole, right? And sure, there's gonna be loss. There's gonna be burn up. Plasma. It's going to turn into plasma and burn up, and there's going to be heat loss. So there's going to be loss. But anyway, in the end result, when it gets to the center of the black hole, which is basically a neutron star, it might weigh more than when it started. Okay, so I call that exponential gravity. And that may or may not be true, and that's okay. It doesn't matter. So here's the thing. And we know that there's black holes. Oh, the reason the popcorn universe, it answers a lot of questions. Recently the discoveries are that there's these galaxies at the edge of the universe that appear to be fully formed. There's, these supermassive black holes, 50 million times bigger than our sun. Take time for that to happen, supposedly. How were they created in such a short time frame, way out in the universe? Sure, there's that. Anyway, so, and then there's the accelerating universe, the expansion and outer galaxies seem to be moving faster than inner galaxies, the separation. I'd even go as far as, we're calling it dark energy. I'm not sure about dark energy. Here's the thing. I'm not sure it's real. Dark matter appears to be real, but dark energy, I think, is questionable. Here's why. Okay, so in the popcorn universe, black holes are in galaxies. They swallow things up. Their gravitational pull increases. And if I'm right about the marshmallow, their gravitational pull then increases kind of exponentially, at least a little bit exponentially. And so their reach is out further. Oh, gravity too. Like magnetism, there's no particles in the magnetic field, actually. There's no magnetic particle, so to speak. And I think gravity's like that. It doesn't necessarily have to have a particle. It's a force, like magnetism, I think. Anyway, so the black hole's reach expands and expands. Eventually, a galaxy's just going down the drain, man, going down the drain, right? But the neutron star in the center of the black hole, if you will, never goes away. It doesn't evaporate. It just becomes larger and larger, like a trash compactor. There's no white hole on the other side. Give me a break. That's just fantasy stuff, okay? So these black holes continue to get larger and larger, supermassive black holes, and I believe their gravity even extends exponentially, and eventually the whole universe starts to collect itself. All these black holes start to collect themselves. That's another thing, is recent observations say that some parts of the universe are coming back together. In fact, our own Milky Way galaxy is being pulled by, what is it called? The Great, Collector or something. A bunch of local galaxies seem to be coming together, and we're one of them. Okay, so all these factors together, they all give credibility to the popcorn universe theory. So furthermore, once all of these black holes, a sufficient number, which would probably be most of the universe in this infinite time thing, come together, think of it, look at it like this gigantic bowling ball of neutrons, right? And the gravity, I mean, these are beyond imagination, these numbers, these ideas. It's just so far out there, beyond what we can imagine. The whole universe collecting into like a bowling ball neutron star, And the gravity will be so immense that, it'll collect everything. It'll collect light, all radiation, everything. But the center will be, essentially neutrons, let's say, and all the radiation around it will, and this is where I'm not sure, but I think it'll start to superheat it, like being in a microwave oven, or not exactly microwave, but surrounded by radiation. And then I could see this bowling ball of neutrons, heating on the outside more than the inside, but heating up in general. And, fusion takes place at somewhere around 10 million degrees in outer space, or something, in suns, 15 million degrees, stars. So at some point, I'm thinking that this is think of hot tar boiling, And when it boils, see, nature repeats itself. We can see this in Fibonacci sequence, okay? So think of a star or sun giving off solar flares, okay? So this bowling ball is being heated by all this external radiation, and I could see it beginning to boil and set off these solar flares. But these solar flares, in this case, is fusion. It's fusion flares, like the sun, but bigger. Like these things are the size of galaxies, let's say. You know, each flare is like the size of a galaxy, that much material. And not only would it just form hydrogen, but at the same time, like a sun, it would form other material, other elements at the same time. And these flares would go out, pop, 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 you know. And so you have concussion, you have, accelerating the outer ones that popped previously, another one. So you have compression waves pushing, pushing, pushing. This would accelerate the outside ones quicker than the inside ones, right? And since these things are going out in flares, you already have gravity immediately taking place. You already have element formation immediately taking place. What this enables is the these galaxies that we find on the outside of the universe that are only 300, million or so years old, fully formed galaxies. This explains that. This also kind of maybe explains dark energy. It's not the energy, it's the compression waves pushing it out, you know, maybe. And the other thing about expanding universe is, I think of gravity, as I said earlier, is kind of a sort of like a magnetic field sort of property. And so as things come further apart, there's less and less drag on momentum. You know, I kind of think of gravity as friction as the universe expands. So if you decrease the friction with distance, then you kind of have a more free, not acceleration, but a free movement without resistance. So it seems as if outer galaxies are moving quicker than inner galaxies. Maybe, maybe not, but it kind of makes sense. So that's it, pretty much. Predominantly, that's the popcorn universe theory. I don't know where I'm wrong because I don't do the math. But I'm kind of thinking this is Nobel Prize stuff here. And I could use the money. So, you know, if you guys want to help me get this figured out, you know, you can certainly have credit for doing the math. What am I forgetting? I don't remember what I'm forgetting. But the popcorn universe theory, it answers, or could, if it's real, answer a lot of these questions and these mysteries that have come about recently. So that's about it. Pass this along, will you? It'd be cool if you know, if it turned into something. It'd be cool. And I might be completely full of shit because, like I said, I don't know how to do the math. So you got me there, and I don't care. But I think that these ideas are pretty cool. Whatever, right? Okay. Thanks for hearing me out. Thanks.